Okay, starts talking about an unbiased estimator on number 5 on lesson 3.3. And I want to use this example here. These were the heights of 4 class members, 62 inches, 65, 67, 67. This was the average height, so we subtracted them. This told us how far each person was from the mean. We squared all those numbers, and we added them together, and we got 16.76. We divided by 4, we got this answer. We were assuming that we were only studying these 4 people, okay? So we used capital N to represent the number of people. The entire population was 4. But what if I was using those 4 people to represent the whole classroom? Or maybe to represent all the girls at West Delaware High School? Do you think if I looked at all the girls at West Delaware High School, there would be more variation or less variation than what we saw with just these 4? More, yep. You start looking at all of them, you're going to get the tallest girls in the high school and the shortest girls in the high school. You're going to get more variation. Meaning this number is probably too small. It should be bigger. Here's the formula that we're going to use if we're thinking of those 4 as only being a sample. Look at the 2 formulas, very similar. The only difference here is instead of that symbol for population variance, we use that symbol for sample variance. Instead of mu for population mean, we're going to use x bar, which is sample mean. Instead of capital N, we're going to use n minus 1. Now that's what we mean by an unbiased estimator. We're going to subtract 1. So let me make the changes that we would make. If we decide that, hey, these people represent a sample, not the entire population, then right here we use x bar for sample mean. Right here, we still divide by n. This would be a small n now. So this would be our x bar, 65.3. Everything would be the same. This would be x bar instead of mu. Everything would happen exactly the same, except we'd have a minus 1 here. So what's 16.76 divided by 3? 16.76 divided by 3. 5 point something, I would think. Someone do that for me? 16.76 divided by 3.
5.58.
5 point what?
58.
So we'll go 5.6. What's the square root of 5.58? 2.96?
36.
2.36. So go 2 points forward. So look what happened to our numbers. By subtracting 1 off the bottom, what did that do to our numbers? Make them bigger or smaller? Bigger, didn't it? When you make the denominator 1 smaller, it's going to make your answer bigger.